let's look at some operations that we can do with vectors. So I have two vectors here. There's A and B, and we've drawn their pictures over here, A and B. And we'll look at what can we do now that we have these lovely two vectors. One thing we can do with a vector is multiply it by a scalar, just a number. So if I have a vector v and I want to multiply it by a constant k, I'm going to do it component-wise. Essentially, I'm distributing the k through my vector v. So k times the first component, k times the second component. Hopefully that's not overly surprising. For example, if I want to multiply 2 times b, I'm going to multiply, here's b, 2 times -3, 2 times 4. If I draw that vector, -6 and 8 is about here, because I have 7 little blocks on my graph here. Here's the vector 2b. And you might notice it's in the same direction as b, and its magnitude is 2 times the original magnitude. So one thing to know about scalar multiplication is that it multiplies the magnitude of the vector by whatever I'm multiplying by. To say that generally, I'd say the magnitude of a scalar multiple of a vector is the magnitude of that vector multiplied by the scalar. My scalar here was 2, and my new vector is twice as long as the original. Something else we can do with vectors, we can add them. We're going to add vectors component-wise. So if I have u plus v, I'm going to add the x coordinates together, and I'm going to add the y coordinates together. So if I want to add a plus b, my specific ones here, I can add 2 plus -3, 3 plus 4. When I do that graphically, here's the way we can think about it. I'm going to take my first vector a, starting from the origin, and then I'm going to put the second one b. I'm going to put the initial side of b at the terminal side, the initial point of b at the terminal point of a. Sometimes you hear this called nose to tail. It makes me think of elephants, the trunk holding on to the tail of the one ahead. So from the terminal point of A, I'm going to put vector B. I'm going to go 3 to the left and up 4. There it is. So there's B that I just transferred over there. The actual vector A plus B, the sum, is what I get from starting at the initial point of A and going to the terminal point of B, like that. So the green one here is the vector A plus B. And if you notice, that matches what we got, -1, 7, to go from the initial point of A to the terminal point of B. I went 1 to the left and up 7. So it all works, which is good. Something else, well, if we can do vector addition, certainly we can do vector subtraction, but first let's talk about what does that mean. Essentially, to make the negative of a vector, I'm going to take it and do a scalar multiplication by -1. So the negative of a vector is, I'm just going to change the signs of everybody. I'm going to multiply -1 through there. Specifically, I'm going to do -b. So -1 times -3, -1 times 4. I can draw -b, +3, -4. Looks like that. And what we get is a vector with the same magnitude as b that's pointing in the opposite direction, 180 degrees in the opposite direction. Well, now that we know we can do that, we can talk about vector subtraction, which is going to be a minus b. And addition with a negative. If I said subtract and then I wrote plus. Let's try that again. If I do u minus b is u plus the opposite of v pointing in the opposite direction. Graphically, we'll do it the same way. I'm going to put the initial point of -b at the terminal point of A. So I'm going to go 3, -4. There's -b. And the actual vector A minus b starts at the beginning of A and goes to the end of -b. So here's my vector A minus b. And let's actually do those. A minus b. We'll do it component-wise, so 2 minus -3 and 3 minus 4. And if we look at the vector A minus b, that's what we did. We went 5 to the right and down 1. Well, look what we can do now. If we can do scalar multiplication and add and subtract, we can make linear combinations of vectors any way we want. Let's find out what's 6b minus 4a. And you can draw them too if you want to. I'm not going to do that with this one. I would recommend going about it carefully. 6b, so 6 times -3, 6 times 4, minus 4 times a, 4 times 2, 4 times 3. And now we'll subtract component-wise. -18 minus 8, 24 minus 12. So operations with vectors.